This video is to guide you through the graphing of radical functions, including square roots and cube roots. Just to remember how you should be doing this, I'm showing you three vertex forms for quadratic and square root and cube root. And the way you would do these is first you would draw a parent function. And if you remember, quadratic parent function has the points 0, 0, 1, 1, 2, 4, and 3, 9. Okay, so you would draw these points first on the graph. And then you would use the transformations that you know to move those points to new points. Okay? What are the transformations? A is vertical stretch. It takes each point's y coordinate and it makes it, 2 times, 4 times, or a half times as far from the x coordinate. The H is the x coordinate of the vertex, the new x coordinate of the vertex, and remember the minus is separate, so you set the minus aside and then you use the h to determine the horizontal translation of the vertex, and k would be the vertical translation of the vertex. Okay, so same thing for each function. The only difference is the radical function, of course, is the reverse of this function. So the radical function has 0, 0, 1, 1, 4, 2, 9, 3, right? And then finally there's the cubic function. The cubic root function. First we're going to draw the cubic function. The cubic function looks like this. It actually exists on the negative side also, because the cubic root function exists for the negative side, because it doesn't violate the vertical line test, right? So if I'm going to cube all these, I'm going to put 9, negative 9, because negative 3 cubed is negative 9. Negative 2 cubed is negative 8. Oh, I'm sorry, negative 3 cubed is negative 27. Negative 1, 0, 1, 8, 27. Right? Now, if I wanted to do the cubic root function, then I need to reverse those. So negative 27, negative 3, negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, 8, 2, 27, 3. Now, our graphs are small, so basically we're going to be graphing this part, maybe the 8s. Okay? Now, let me show you how one works so that you can see the whole picture. Okay, so first one here, I look at this, I compare it with the vertex form. The vertex form tells me that I see 3 parameters, which tell me how I'm going to transform it. And in this case, I really only have one parameter, and that happens to be the k parameter. How can I tell it's the k parameter and not the h parameter? Because it's outside the radical, right? It's outside the radical, so it's the k parameter. And I need to be careful because normally it would be plus k, and this says minus 2, so the k value is actually negative 2. What about the a value? Is there an a value? Well, I guess technically there's an a value, but it's 1, right? Because there's something multiplied times the square root of x, which I can't see, because since it's 1, we didn't write it. And so the a value is 1. When the a value is 1, basically it doesn't do anything, right? The way you're going to use this video is you're going to stop the video frequently. You're going to try to work ahead and see if you can do it by yourself. When you can't do it by yourself, you're going to use the video to give you hints and to finally give you the solution when you're done. Okay? So in this case, why don't you stop the video if you already know how to do it and go ahead and do it. If you don't know how to do it, the first thing I'm going to do is I'm going to graph the square root, the parent function of the square root, which is 0, 0, 1, 1, and 4, 2. And not only am I going to graph those points, I'm going to draw a smooth curve through it. Okay? That's the parent function in blue. Now I'm going to do the translated function. The translated function is take the parent function and move it down 2. So instead of this point here, I'm going to draw this point here. Instead of this point here, I'm going to draw this point here. You can see I'm drawing each point 2 units down. Okay. Now it tells you to state the domain and range. And if you remember how to do that, go ahead and do it, and then you can check your answer later. If you don't remember how to do it, let's talk about that. Okay. So if we look at this picture of the red function, when does it exist for x? Well, it exists here to the right, right? And what is here? This is 0. X equals 0. So the domain can be stated as x is greater than 0. Should I put greater than or equal to 0 or greater than 0? Well, does it include 0? Yeah, there's a point right on 0, so I should put greater than or equal to 0. The range says that this function exists from this point up, right? This point is -2. So I'm going to say y is greater than -2. Should I say greater than -2 or greater than equal to -2? Well, it includes the point -2, right? So let's put greater than or equal to -2. Okay, and that's a complete problem. The next problem, we have negative square root of x minus 3. And this has 2 parameters which are causing a transformation. It has this one, and it has this one. This one here would be a equals -1. And this one here would be h equals 3. Okay? So a equals -1 would cause a vertical stretch of factor -1, which you might think, that's kind of weird. What would be a -1 stretch? Well, if you remember, negative in the quadratic function makes the quadratic function invert. So instead of opening it up, it opens down. So the same thing would happen with the radical function. If you have a negative for the a value, it's going to turn it upside down. So first I'm going to draw the parent function for the radical function. We know it looks like this. And then I'm going to apply the 2 transformations. The first transformation is a equals -1. So what I'm going to do is I'm going to turn this upside down. So every single point is going to be reflected about the x-axis. Okay, so there's my new function, and all I've done so far is the a equals -1 transformation. Now I'm going to do the h equals 3 transformation. How do I know it's h equals positive 3 and not h equals -3? Well, it's -3, so that means if I match it up with the vertex form, I can see that the h corresponds exactly to the 3. So h is positive 3, which means I'm going to move 3 to the right. So now I'm going to take this green function, and I'm going to take each point, and I'm going to move it 3 units to the right. Oops. Okay, and then I'm going to trace the line through it. Okay, so there is my new function. What is the domain and range? If you know how to do that, go ahead and pause and then try to do it on your own. So if I look at the x values for the red function, I can see that they exist from this point to the right. This point is x equals 3. So I can say that the domain is x is greater than or equal to 3. For the y values, I can see that it exists from here down. This would be y equals 0. So I would say the range where the red function exists would be y is less than 0. Would it be y is less than 0 or y is less than or equal to 0? Well, since it includes the point y equals 0, I would say y is less than or equal to 0. So the first step for number 12 is to identify a, h, and k in the cubic root function. So how about if you do that, and then after you do it, come back to the video and check your answer. So pause. So the answers are a equals 1, h equals 3, and k equals 0. A is tricky because it doesn't show up there, but it's there, right? K is tricky because it also doesn't show up, but it's right there. And h, you might have put down -3, but remember, the negative is already included in the vertex form. It's minus h, so h equals 3. Now, go ahead and pause the video and draw the parent function for the cubic and the cubic root. And I hope you wrote it down in your notebook, but basically it's the t table that we talked about before. Pause. So this is the t table for the parent function for the cubic root function. Now, go ahead and pause and graph this. So here's the cubic root function graphed as the parent function. Now I'm going to do this translation, or transformation, which is with a equals 1, h equals 3, k equals 0. Pause and do it. You can see that what I've done here is I've taken each one of these points and I've moved them 3 units to the right, and that's all I did. So my red function is the new function. Now think about what the domain and range of this function are. Go ahead and pause. You might remember that functions which go on forever in both directions, for the domain, the x direction, you would write x as an element of all real numbers. And that's the case for the cubic root function. It's not like the square root function where it's only half the graph. Range, same thing. It exists for all possible y's. Okay? So move on to the next problem and figure out what the a, h, and k values are. So pause and come back to the video. Here I've picked out my values. The 3 is obviously multiplied at the front. The -1, this is a tricky one because it's x plus 1. Actually, x plus 1 is the same thing as x minus -1. So that means our h value is actually -1. The k value doesn't appear because it's outside the radical, and there's nothing outside the radical. The way you tell the difference between h and k is h is inside the radical and k is outside the radical. Now, why don't you pause and graph this and come back. Oh, graph first the parent function for the square root. I've graphed the parent function for the square root. Now, I want you to pause and I want you to graph a vertical stretch by a factor of 3. So each one of the points of the blue function are going to get 3 times farther away from the x-axis. So here I finished it. The height 1 point becomes height 3. The height 2 point becomes height 6. And of course the height 0 point just stays at height 0. Last of all, I want you to do this transformation, h equals -1, which means you're going to move it 1 to the left. Okay, so I want you to do that and pause. So here's my answer, the new red function. And now the last thing I'm going to do is I'm going to define the domain and range for it. So if you know how to do that, go ahead and pause and do that. So first thing I did was I defined that the x values go from x equals -1 to the right, and the y values go from y equals 0 and up. And now I'm just going to make that into inequalities, and I'm going to write them down here. So go ahead and pause and do that. And there's my answer right there. Okay? Now I want you to go to the next page, and I want you to do these slightly more difficult ones. So the first one here, I want you to start by drawing the parent function and identifying a, h, and k. Okay, here we've identified the h and the k values both as -2, and the a value is just 1, and I've drawn the parent function. Now, I would like you to do the first transformation, which is -2, 2 to the left, and then come back. Do you see how I've taken each one of these points here and moved it 2 units to the left? That formed one transformation. The next transformation is to lower it by 2, go 2 down. So do that, pause and do that. So here I've drawn my final transformation, and I've marked where it exists on the x dimension, where it exists on the y dimension, and now I can write my final inequalities to define the domain and the range. So pause and do that. So here are my inequalities defining domain and range. Now go on to the next one, and I want you to draw the parent function for the cubic root function, and I want you to find a, h, and k. So here I've defined a as 1 and k as 1 because k is outside the radical, and h is 0 because there is no addition or subtraction inside the radical. And I've drawn my parent function. So next step, I want you to do the k translation, which would be a vertical translation up, and then you're going to be done. So pause and do that. So you can see here that I've taken each point and I've moved them up 1, and I can see that the red function is the exact same thing as the blue function. It's just moved up 1 because the a value is 1, so it didn't get vertically stretched. Now I can see that also that the function is going to go up and down forever, and it's going to go left and right forever, so then I can write my domain and range correspondingly. So go ahead and pause and do that. Okay, so we have our x is an element of real numbers, y is an element of real numbers. That's how you note that there are no limits to where the function exists. Okay, so now I want you to go to number 9, and I want you to graph the parent function, identify the a, h, and k. I want you to do the transformation step by step for a, h, and k, and then figure out what the domain and range are. Once you do that, come back and check your answer. So I can see that now the a value is 3, and the parent function looks like this, and the 3 points that are identified on the parent function, I have stretched them vertically 3, so the one that is 1 below the x-axis becomes 3 below the x-axis, and the one that is 1 above the x-axis becomes 3 above the x-axis. And of course, the domain and range are going to be x is an element of real numbers and y is an element of real numbers. Now I want you to do the next problem. I want you to identify a, h, and k. I want you to draw the parent function. Then I want you to execute the transformation in 2 steps, and then come back and check. First step is I've translated everything 2 units to the left because I can see that the h value is -2. Next step is I see that the k value is -2, so I'm going to go down from the green graph to the red graph 2 units down. So this is my new graph. So now we can see that with the cubic root function, the domain and range are always x is an element of R and y is an element of R. How about doing this one here? Do the parent function, identify a, h, and k, do the transformation, identify the domain and range, and then come back and check your answer. So you can see that I went through 2 steps. First, I changed the blue graph to the green one, and then to the red one using the transformations a equals -1 and k equals -1. And as with all cubic root functions, the domain and range is x is an element of all real numbers and y is an element of all real numbers. Now I want you to see if you can do backwards. Take these graphs and try to figure out what the a, h, and k values for each one are. So figure out what a, h, and k are and come back to the video. So are these the answers you got? Okay, this is a little tricky. It's upside down, so it's a equals -1. Now I'm going to put it into the vertex form equations, and then you'll see what the final equations look like. So first I just substituted the a and the h values in directly, and then I simplified. So this is what you should get. That's it. Thanks for watching.